Chapter 13, sample problem number 8. A cart is attached to a spring and is displaced from equilibrium and then released. There is no friction. A graph of displacement as a function of time for the cart is shown. The signs and arrows above the cart indicate the positive and negative directions for the position of the cart. For each question, choose from the points above or state none. At which point or points is the acceleration positive? So we don't really even need to think about it being an oscillator. We know that for position time plots, that frowny graphs have accelerations that are negative and smiley graphs have accelerations that are positive. So we're really looking for things that are in this range, which are none of our points, or this range. And so we would say that in this case, the acceleration is positive in cases D, E, and F. The acceleration is 0 at C and G because the displacement is 0, and the acceleration is proportional to displacement in the spring system. At which point or points does the cart have 0 velocity but non-zero net force? So 0 velocity, of course, will happen at maxes and mins, where the slope is 0 because the tangent line is horizontal. So we're talking about either A or E, and we want non-zero net force, and that's actually true at both of those places because when the cart is not at equilibrium, then there is a net force. So since A and E are not at equilibrium, there we go. At what point or points is the net force equal to 0? Well, then we need to be at equilibrium, so our only candidate points are C and G, and in fact they are where there is net force is 0. The displacement is 0, the acceleration is proportional to displacement, so the acceleration is 0, so the net force, which is the mass times the acceleration, is 0. At what point or points are the acceleration, velocity, and displacement all positive? This is never, because the acceleration is minus some constant k over m is times x. So if x is positive, a is negative, and vice versa. At what point or points is the acceleration non-zero, but opposite in sign to the position? Well, it's always opposite in sign, right? It's always this. So really we're just saying, where is the acceleration non-zero? And it's non-zero anywhere there is not, we're not in equilibrium. So at A and at B and at D and at E and at F and at H, anywhere that we're not in equilibrium position. At what point is the velocity non-zero but opposite to the acceleration? So we're talking either B or C or D or F or G or H, and we need the velocity to be, say, positive and the acceleration negative. So we need it to be either sloping upward. I guess what we really need to say is we need to be on a curve that looks like this, or we need to be on a curve that looks like this, the first half, the rising part of either thing. So we're talking that maybe the velocity is non-zero and the acceleration is opposite, so C is out because there's no acceleration there, but D would work, and then H would also work.